Hello, Talk Funders. Again, we're going to do a Talk Funding deep dive with Rajiv from Palmy Systems. Hello, Rajiv, my friend. I really just picking up from the main interview, which we've just finished, and I recommend people to go back and look at that main interview sort of for a broad stroke. But in this deep dive, I really want to get into the technology of what behind your product that you're live on WeFunder with. The whole idea of how Palm Energy Systems is going to build an innovative solar energy network. So one thing I noticed from the WeFunder page is you were originally talking about questioning first principles. So maybe we can start the deep dive by looking about what do you mean by questioning questioning first principles?
By questioning first principles, we are basically questioning the whole premise of how renewable energy systems have permeated into our lives over the past 20 to 30 years, ever since they've been invented. And what we found is that the renewable energy space, and specifically the solar energy space, is dominated by the solar panel, which is a rectangular, heavy, ugly piece of equipment. And while the solar cell performance parameters have improved significantly over the years, the shape and size and form of the panel has remained exactly the same. And we asked ourselves, why is this the case? Because what happens is that because of its form and structure, its usage is very limited. You have to either put it on top of a roof or on top of a solar carport, or shun it into the remote areas of your deserts, as solar farms. Whereas when you walk around your towns and cities, you find huge spaces which are lying empty, which get the sun in abundance, but which cannot have a renewable energy system, because these systems do not lend themselves to living with human beings. Because historically, if you see, the human being is very sensitive to aesthetics. And unless something has a certain qualitative aspect to it, it does not deserve becoming a part of our towns and cities, as part of our direct environment. Because it would hurt our sentiments. It would hurt our entire day to night sort of operations. I mean, what we do from day to night. I mean, imagine having an ugly solar panel, and they have them. You have people in their backyards have a little post with a little rectangular panel stuck onto it, but it hurts your sentiments. You don't want it there. So this is the first question we asked ourselves. What if you could develop and build something that could actually live with human beings? And that was the first questioning of the first principles.
Oh, that's absolutely awesome. And in one sense, we'll look at the team elements in the backstory. But Rajiv is an architect by training, and by the sound of it, it's very like human-centered design. The whole one way you're looking at this is human-centered. You're actually thinking about how the end user, or the person who's going to be dwelling around your product, is going to be interacting with it. And you're talking about aesthetics and everything. You're just not building something which is rude and ugly, which is pure function. You're thinking of form as well as function. Absolutely superb, my friend. Can we just more in the deep dive, just actually begin to look in terms of what you are going to be putting where people are living, in terms of where people are dwelling, and that idea of human-centered design. If the WeFunders, like Talk Funders, click through and look on the WeFunder page, you can scroll down and there's actually see systems here, or sorry, diagrams regarding, there's a whole about building and testing the virtual prototype. So can maybe for the science audience here, can we really begin to just look at that, about what you're talking about in terms of the raw science of the product?
The science of the product is very simple. It is a device that has to soar above us so that it can allow activities to happen below us. And in order to soar above us, it needs to have a small footprint. Whereas at the top, it has to have a large footprint because it needs to collect solar radiation. So that gave the basic form to the structure. The second important factor is that the solar array, the solar petals, are very light. They're built out of advanced materials. And because they are light, they need very little force to move them. So if you compare our solar array with a conventional solar panel, it is 70% lighter. So what happens with a conventional solar panel, if you want to move it around, if you want to sun track with it, you need heavy motors, you need levers, you need all kinds of axles, and that makes the whole structure very complicated because you have so many different moving parts that need to be maintained and that need to perform. It also makes it expensive because those motors consume a lot of energy. And some thumb rules tell us that the amount of energy a conventional sun tracking system saves, it actually uses in maneuvering to track the sun. So we decided that our array would be very light. The sun tracking mechanism would be very simple. It would be a single point kind of device. And because the array was light, it would require less energy to move. And then we built this device and we tested it structurally and from the point of view of energy performance. And when you test a structure structurally, you have to conform to certain factor of safeties. And the factor of safeties are decided on the basis of certain forces that you apply on the structure as a simulation within very sophisticated design programs, structural engineering programs. So we simulated these structural engineering calculations and applied certain forces to the device, to the array, from the side, from the top, from various angles. And we created 3 cases, case 1, 2, and 3. And we found that in each of the 3 cases, we are well within the factor of safety that is required for a device of this kind. The second parameter which we tested the structure was from an energy performance point of view, because the primary purpose of this device is to create solar energy. So we simulated its energy performance again on sophisticated energy simulation software and found that it generates the amount of energy that we expected it to generate. Now, an interesting fact is that when you see the device, when you see the array especially, you feel that it's curved. And a lot of people ask us this question. Well, if it's curved, then a lot of the cells won't really face the sun. They would sort of be not in the ideal angle, whereas you're claiming that your device is sun tracking, and therefore it is very efficient. So I just wanted to mention that the actual curve of the petal is very scientifically designed to ensure that 80% of that area of 60 square meters, which is a radius of 30 feet, a diameter of 30 feet, 80% of that panel is actually flat. And it's only within 20% that we have a slight curve, which reduces the efficiency by 152 kilowatt hours for the whole year.
Wow.
So these are small nuances to do with the design and the technology and the proof of concept that we worked on.
Really, it sounds as if it's like 2.0 it's like, you know, we had the internet 2.0 or social media 2.0, and now this is like solar energy network 2.0. Like your guys have said that's what's happened in the past. This is where we're going from now into the future, which sounds to be it's, you know, and I get that. I understand it, because it's like the technology has moved on so far, and you're utilizing cutting edge technology, and it's made it a lot more lighter, a lot more adaptable, modular, etc., flexible in its use, which cuts down on actually the energy that is needed to actually get your energy generated, because we always forget about the energy that's generated. Like, we've been using the carbon for so long, for over hundreds of years, to get that going, you know. So absolutely phenomenal. Can I just ask you like a more simpler question?
Sure.
So what is you were mentioning about the size of the petals. So what is the actual, and I know in the main interview you brought up about the prototype is going to be, I think, 1/4 the size of the main prototype. And again, you're doing a great, you've got a design company coming in from Barcelona in Spain. What is the size of the fully built Palmy going to be, and what's the size of the petals? How does that all work together?
It's 10 meters high, that's 30 feet high, and 10 meters wide, that's 30 feet wide.
And how many petals will it have on it?
It has 6 mega petals and 12 minor petals. So each mega petal is broken into 2, because we designed the petals based on the size of a transportation container, because we need to transport these all over the place. So while the mega petal does not fit into a conventional container, the segment of the petal fits into a container. So therefore we broke up each mega petal into 2 petals, which come together to form so you see a fine joint, but they're actually 6 petals.
Wow. I love it. And it really is like the basis of this, going back to the initial first principles, is, you know, about the actual human-centered design process, but also it's like organic design principles. It really is botanical in its nature as well. Even just the word petal that you're talking about, and Palmy, it's really is like idea of harmony between humankind and nature, and leveraging that knowledge and that symbiotic relationship. Absolutely fantastic. Right. So can we scroll down now just to the next part of in the wee funder page, where you really are talking about the Palmy technology, the Palmy tech platform. So once this is built, you know, you've got 10-meter high, you've got a 10-meter high tower, so we say, with the petals on it, and then you can also network them all together in a localized area to service like a neighborhood development, or a, you know, college campus or a corporate campus. So we get all that. Now, how does that all work then? How does, like, you move from the one Palmy to the multiple Palmy, and how do they all connect together, talk to each other, etc.?
It's a modular device. So what we've done is we have separated the power producing unit from the human interaction unit. So when you see an image of the Palm E, you'll see a little base unit alongside it. You know, that base unit is called the seed. And the seed houses all the electronics and the batteries. And it's modular, so you can expand 1 seed or 2 seeds or 3 seeds. And we have 3 types of devices. The first type is a fully autonomous device, which does not depend on your electrical grid at all. So if you want to install it, for example, somewhere remote, say in Yellowstone National Park, where there's no electricity, and you want to charge electric vehicles, then you have a full battery backup system, which doesn't connect to your grid at all. It just is completely self-sufficient. The second type is a hybrid unit, which has a part battery backup and a part grid connect. And the third is a fully grid connect, which you have in urban areas where you don't need battery backup, you know. So the modular nature of this whole system allows us a large amount of flexibility and versatility in where we can apply it and how we can apply it and what the system can do.
Oh, fantastic. And And then the software, like how is it all connected together? I mean, how are they a view to having to, I mean, there's so many in one sense. One sense I get it, there isn't as many moving parts, but there is a number of moving parts which you are having to assemble together and the different elements of your team, etc. How have you connected these all together, in terms of you'll be able to remote access each plant, etc.?
That's right. That's right. So the base station typically is connected to the remote technology platform through 5G or through Wi-Fi or whatever technology is available at that particular location at a given time. But we are flexible. We are designed to support 5G too, and it'll be great if we can have people who ask for 5G. So the base station connects to the tech platform and receives instructions from the technology platform, and in turn transmits them to the device, which then moves in a certain way based on what it's told. And what it's told depends on a number of parameters: weather parameters, climate parameters, performance parameters, whether a storm is approaching or not approaching. The technology platform is mapping and collecting data on all these locations in real time from a whole host of databases, and then it transmits them to the devices or to the entire system based on what it recommends the system to do.
Fantastic. Absolutely superb, my friend. Thank you so much for taking part in this Talk Funding Deep Dive today. I'd like to thank Rajiv from Palm Energy Systems, who are live on WeFunder, and all the links will be in the video description below. And really, I can really see from this deep dive how you really are creating an innovative solar energy network. And it really is where we live, work, and play. So thank you very much for taking part in this deep dive today, Rajiv, my friend. We'll go on to the backstory interview, which is really looking at the team, very much. The team and the market potential of your product. Thank you so much. Bye bye now.
Thank you, Alan.